Okay, we're looking at my Torque Pro application running on my Acer tablet, just focusing on the intake air temperature using the Bosch open element sensor, and the resistance is slightly off, and so the intake temperature is reading about 6 degrees too high, and so you could solder in a resistor to increase the resistance and lower the temperature, and I decided to be able to solve this problem along with heat soak at idle to be able to tell the ECU that it's colder than it actually is reading by installing a little rheostat there. This is my helper Erica, who's just checking things out here. So anyways, if I turn the dial just a little bit here, you can see that the temperature has dropped down to 16, 15, 14, 13, 12. So that's about right. So that's where I'm going to leave that, and I'll show you guys the harness in just a second here. Okay, as far as monitoring ODB outputs, I'm not a fan of gauges on the A-pillar or hacking up the dashboard, so I found this to be a cheap, inexpensive solution. 7-inch tablet with a bit of Velcro on the tops and bottoms, and then the other side of the Velcro there, and then the tablet just slides into place and stays very stable. Then as far as the Bluetooth adapter I've chosen to use, it's this one here, which seems to work very well so far. I've had it for about a year and no issues so far. Okay, so this is my 2011 370Z. Got the Stillen Supercharger installed, and I was having issues with the MAF readings close to 5 volts and not being able to get stable AFRs, so with Sebastian at Specialty Z we've converted over to speed density tuning. So I've installed a GM 3-bar map sensor there that tees in right off the regular intake manifold. You can see my finger there, just tees in there, and then I've found the correct connector so you don't have to hack into the OEM harness, and there is your map reading for your speed density tune. And then if we're getting an accurate air temperature, there's no way that the the reading from the MAF is correct. And so what I've done is I've got the Bosch open element sensor, which is used in a lot of forced induction applications, and then that gets wired in to, I've also got a 6-inch extension, probably 12-inch extension. Rather than hack into the harness there, you can see that I've cut 2 wires, pin 1 and pin 2, and pin 1 is the, there it is there, far right black, that's your 5-volt reference, and then the second pin over it is the pinkish color, and that's the signal back from the resistor inside the air intake temperature sensor. And so I've got my potentiometer wired in there as well, so when I turn the dial I'm increasing the resistance, so I'll put this all together and make it look a little better. But we're good to go. And one note there, on my particular sensor, they come with a brass ring inside there, and the geometry doesn't line up, and so I had to take the brass ring out in order to be able to bolt that guy in place. I take it to the track a few times a year. It's the Mission Road course. It's very hard on brakes. It's a flat course, and I found the airflow insufficient with the stock front clip, and so went to the Stillen clip. Fits reasonably well, but not perfectly. And got the oil cooler and transmission cooler in there. This is a 7-speed automatic transmission, which with the up-rev tune was not that great for the transmission in terms of stock-like drivability, but substantial improvement with Sebastian's tune using EcuTek at Specialty Z. Anyhow, I'm going to be switching over to the Frozen Boost intercooler in the spring, because I was experiencing heat soak issues on the track as well as on the dyno, and so that should make, according to most people who've installed it, pretty significant difference in terms of keeping intake air temperatures cool. Otherwise your engine ECU is just going to pull timing, and you'll be losing a lot of horsepower on the track. Okay, so a bit more on the speed density tuning. Got the wiring cleaned up, and just for clarification, as noted before, on the far right is the black 5-volt reference signal, pardon me, the voltage, and then the wire next to it, pin 2, is the pink, and those are the two leads that need to be snipped. And so here's the extension that I purchased, and basically you're going to cut down at this end here the two right hand wires, and then that connects to your intake air temperature sensor, which I said before is the bar sensor, and that is a very snug fit into the stock map sensor location. And then what we got going on here, according to a document from Vortec, the temperature increase is about 120 degrees at 10.8 pounds boost, and that consumes about 50 horsepower. So it still indicates somewhere that their intercooler knocks the temperature down by about 100 degrees, and the Stillen kit puts out about 8 pounds boost. So in theory, I guess if the intercooler is nice and cool, the intake air temperature is going to be close to ambient, but that's not what I'm experiencing. I'm seeing about a 6 or 7 degree increase in temperature between ambient and what's going on inside the intake manifold. But so far it's working out quite well. The issue we're working on now with Sebastian at Specialty Z is a bit of pulsing in the map signal, and so I'll have more on that later. So just a couple of side notes for those of you who are interested in tracking your 370Z, what I've found. Back to the stock exhaust, which if properly tuned will give you about 400 horsepower at the wheel with the Stillen kit. Early on I thought that I'd want to increase the flow by putting in a better exhaust, and talked to an online Z shop and asked them for the recommendation between a balance of flow and too much noise, and so they recommended the Motordyne ART pipes and shockwave exhaust system, and got different reactions depending on the crowd. The guys who installed it at RG Racing thought it was one of the greatest exhausts they'd ever heard. My wife asked what happened to my car and why does it smell like a snowmobile. And first day out on the track, I was greeted with the black flag from the course marshal at 98 dB, so back to the stock exhaust. As for brakes on the track I go to, Mission Raceways, is very hard on brakes. This is my third set of rotors. Started with stock rotors and stock pads as a newbie, bad idea. Went then to StopTech pads and Ferodo DS25, StopTech rotors, pardon me, and Ferodo DS2500 pads, and I think those even got too hot because I had uneven pad deposition on the rotors, and so I'm now on Concept Z 2-piece rotors and EBC yellow stuff pads. I haven't had that set up on the track yet. We'll see how it goes. Although reading some information on forums from the Corvette guys, I may end up just going to stock rotors and getting Carbotech pads that can take the heat. Okay, another thing I wanted to touch on, this is a box containing a flex plate from Fast Intentions. There's been a lot of information on the forums regarding 7-speed automatic transmissions and forced induction, and my experience with my Stillen Supercharger installed for almost a year. Don't drive it hard on the streets, my daily driver, but when I take it to the track, drive it as hard as I can. I have no issues whatsoever with my transmission in terms of slippage, but just as a precautionary measure, I've got this flex plate from Fast Intentions. They, along with Sebastian at Specialty Z, know what they're doing. They've got a Z car that's got over 680 wheel horsepower and an automatic transmission, and according to their transmission builder, the 370Z stock 7AT is good for about 450 wheel horsepower, and then after that you'll want to change the clutch packs, which the guys at Fast Intentions can help you do, and at some point I'll get this flex plate installed, if is that as a precautionary measure, or if my flex plate does let go like others have experienced, then it's going to be going in for sure. And the other thing I touched on earlier is that the transmission tune from up rev leaves a lot to be desired. You don't really have the resolution and the control you've got through EcuTek, and Sebastian's done a fantastic job tuning my transmission to get it to drive almost like stock when you're light on the throttle, and then crisp, fast shifts under load.